Welcome to Luca is a Billionaire, where the only thing I invest in is your answers.
You start by assembling the key hardware and doing the first wiring so you have a working baseline. Connect the IMU to the Arduino I2C pins and secure power with a decoupling capacitor to prevent noise spikes. Mount the ESC signal wires to PWM-capable pins and attach the RC receiver outputs to separate input pins, labeling each channel. Once done, power the system briefly and open serial monitoring to confirm the Arduino and IMU respond, which proves your basic wiring and communication are correct. Now you move into software, flash firmware that reads sensor data, fuses it, and controls motor outputs. Start with a tested MPU driver and sample at a steady rate, then implement a complementary or Mahoney filter to combine accelerometer and gyro into a stable attitude estimate. Next, translate RC stick inputs into target angles and run 3 independent PID loops for roll, pitch, and yaw. Make sure to constrain output signals to ESC PWM range and add a simple arming switch so motors won't spin unexpectedly when testing. Finish by validating behavior and tuning, then add safety features. Begin bench testing with props off. Verify motor rotation and ESC calibration, then arm and observe response to stick inputs. Tune P gains first until responsiveness is crisp, add I to correct steady drift, and only then add D to damp oscillations. Once stable, mount props for a cautious hover test. If you see oscillation or sensor drift, recheck IMU mounting orientation, increase filter bandwidth, or adjust sample timing, and mitigate power supply noise with better decoupling.
Thanks for watching and please subscribe. It's the best investment you'll ever make.